Hey everybody, it's What's Up with Giancarlo. You're tuning into a great episode right here. We've got topic 12, lesson 7. Understand experimental probability. All right, let's get into it. Example 1. Determine relative frequency and experimental probability. So, real quick, last lesson, lesson 6, was about theoretical probability, which is what should happen. Before you run an experiment, it's what should happen in the situation when you go do it. Flipping a coin, you get heads or tails, that's 50-50. But when you do the experiment and you actually flip the coins, something else can happen. That is what experimental probability is. All right, so let's get into it. If you roll a number cube and land on a 6, you win a prize at the local Hispanic festival. Cecilia tracks the number of players who roll a 6 on Saturday and Sunday. What percentage of players won a prize? So if we look at this, Saturday, there were a total of 125 players and 22 winners. On Sunday, 138 and 28 won. Okay? So in total, out of both days, we had 50 winners out of 263 people. Okay? So if you take out your calculator, 50 divided by 263 gives you, we're going to round to the nearest whole number, and we're going to say approximately it's, so if you do it on your calculator, you get 0.190114068444106, blah, 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 blah. Okay? We're just going to round it. All right? So you get 0.19, and that, of course, would be 19%. So about 19% of the players that played the game won a prize. Okay? So we look at step 1, determine the relative frequency of winners on Saturday and Sunday. They work it out to find out the relative frequency for Saturday and Sunday. You can do that. You can. Or you can just go straight to the total because that's what they give you. If they don't give you a total, you just add up the winners from both days and the total players from both days, and boom, your total. All right? In a probability experiment, you carry out or observe an action repeatedly. They're talking about the players playing the game and us finding out how many winners there are. Each observation of the action is a trial. Okay? The relative frequency is the ratio of the number of times an event occurs to the total number of trials. Okay? So it's just the ratio of winners to total players. All right. Ratio of winners to total players. That is the relative frequency in this experimental probability. Step 2, the relative frequency of an event can also be called experimental probability. So, relative frequency is also known as experimental probability. Okay? Same situation that we had for theoretical probability. The probability of an event happening. Okay? Number of times an event occurs over total number of trials. Write this down for experimental probability, please. So in this situation, the experimental probability was the probability of rolling a 6. It happened 50 times out of 263. That is approximately 19%, like I showed you. So based on the data, there were actually 50 winners out of 263 players, or about 19% of the players that rolled a 6. Okay? All right. Example 1, try it. During the following weekend of the Hispanic Festival, Cecilia recorded 47 winners out of a total of 275 players. What is the experimental probability? Okay, quickly pause it and you try and work this out real quick. All right, you should have paused it. So experimental probability, the bottom number is the total amount of trials ran, and the top is the favorable outcome or the times that it happened. So there were 47 winners, so 47 goes here. And then on your calculator, you do 47 divided by 275, and that will equal 0.170909090909090909090909. All right, so we're just going to say it's about 17%. So the experimental probability is, not is, but it's about 17%. We're rounding that. Heck, we can go 17.1%, doesn't matter. 17%, it all depends on what the question is asking you and what it mentions, okay? If it says round to the nearest whole number, boom, 17%. If it says round to the nearest tenth, 17.1, okay? All right. Example 2, use experimental probability to make predictions, okay? To make predictions. Joaquin also kept track of players and winners for his game during the Hispanic Festival. Based on the results shown in the table, how many winners should he expect if 300 people play his game? Okay? Use proportional reasoning to predict the number of likely winners, W, based on the experimental probability. Okay? So they show you can multiply both sides by 300, get W. This is perfect for bat and ball. Okay? So we just take the total and we make the ratio out of that. So winners over the total players. So we get 71 over 416. And that's going to equal the amount of winners, whatever that is, they make it W. I'm just going to leave it blank. Over 300 players to play the game. All right? So here we can go bat and ball. We should all know bat and ball from other lessons. So we draw a bat around the two numbers across from each other, and then I like using red for the ball. And then a red ball for the last number that's left. All right. So everybody should know the bat multiplies. So we get 300 times 71. And that equals 21,300. Then we take the ball and divide that 21,300 by the ball, 416. And that will give me our answer. And they rounded to the nearest tenth, so will we. We get 51.2. About 51.2. I'm going to do, so the little squiggly lines are approximately, it's about, all right? Joaquin should expect about 51 winners out of 300 players. Why 51? Can you have 0.2 of a person? No. And 0.2 is lower than 0.5, so we are going to, well, it's 4 or lower, so we're going to round it down to 51. Okay? Example 2, try it. How many winners should Joaquin expect if 450 people play his game? Whoa. So we have 71 over 416. Let's just do bat and ball again. 71 over 416 equals something over 450. That is a 5. So, bat and ball. Let's get it. Boom. Boom. Boom, boom, boom. Bada bing, bada boom. All right. So 450 times 71 equals 31,950. Now, we take that and divide it by 416. And we end up getting approximately 76.8. So, technically, when it's people, like we would round up to 77, but technically, since it's human beings, I don't think we would round up. I think we would just say Joaquin should expect 76 people to win out of 450 people. All right. Example 3, almost done. So example 3, simulate a probability situation. In a carnival game, the winner is randomly given one of 4 prizes. How can you simulate a winner being given a prize? Okay, so we have a spinner, A, B, C, D. The spinner has 4 equal sections. Each equal section represents one of the 4 prizes. So step 1, design a simulation using a spinner. Boom, we got the spinner. We all good. A simulation is a model of a real-world situation that can be used to find probabilities. Step 2, run the simulation by spinning the spinner. That is you just flicking the spinner and keep going, okay? So you do it. So you run the simulation. You do your number of trials. You do 10. Then eventually you get to 25. Then eventually 50. Then eventually 100, okay? So we're looking for the number of A results every time you spin it and it lands on A. The experimental probability of winner receiving prize A ends up. So the experimental probability, we're finding the percentage, 4 out of 10 times is 40%. 9 out of 25 times, 36%. 11 out of 50 is 22%. 24 out of 100 is 24%. Okay? The table shows the number of times that the spinner landed on A after many trials. Step 3, analyze the results. After more trials, the experimental probability of a winner receiving a certain prize gets closer to the theoretical probability of 25%. So the simulation accurately models the situation. So what they're saying is, in a regular situation, it should land on A 1 out of 4 times. Okay? And will that happen if you just spin it 4 times? Not necessarily. It could not land on A at all. It could land on A 3 out of 4 times. It's just the more you do a situation or simulation like this, the more likely the actual experimental probability is going to get closer to the theoretical probability. And that makes the simulation accurate. Okay? We started out with 40%. Then it went down to 36%, then 22%, and then it was 24%. 24% is very close to the 25% it's supposed to be from the theoretical probability. Okay? And that's it. All right? So the key concept is telling you that the relative frequency is also known as the experimental probability, and it's based on the actual results of an experiment, okay? Theoretical is before we do anything, what should happen, and then the experimental probability is after we actually run the trials, and that is what happened, okay? Also, this was example 3. The experimental probability tends to get closer to the theoretical probability as more trials are conducted. I could flip a coin 10 times. It could be heads 9 times out of 10. But if I do it 40 times, 50 times, 100 times, it should get closer to that real 50%. I should get heads just as many times as I get tails. It should be close. All right? Thank you for tuning in to What's Up with Giancarlo, and I will see you next video. Remember, if you're watching this video, you're a part of the class. See you next time, everybody.